So let me start with this quotation. The war has brought home to all the nations engaged in it the overwhelming importance of science and technology to national welfare, whether in war or in peace. In this talk, I will elaborate and defend this claim, or more exactly the basic claim behind this 1919 assertion of the American Federation of Labor. Namely, what I would like to defend is that the First World War significantly strengthened the view that science is a key for material welfare, a view which was shared by most public figures and powerful forces like this American trade union, also commercial companies, and many in the governments. In the terms of the current conference, I will show that the experience of the war, and especially the research during the war, raised the expectations from natural sciences. Scientific research became a promise for economical growth. This was not completely new, of course, yet before the First World War, the potential benefits of scientific research in answering practical technological problems had been fiercely contested. The success of scientific research in fields like submarine detection, sound ranging for locating enemy artillery, wireless communication, and the infamous development of poison gas, convinced many of the skeptics about the value of science for technology and society. Many expected that once employed for good causes, science would be a strong force in ameliorating human welfare. Historians have pointed out that advocates of scientific research had raised similar claims about the necessity of science for the development of modern technology also long before the war. Nevertheless, I claim that the war did make such voices more influential, and that individuals and organizations that were less enthusiastic about the combination of research in the industry, like this American Federation of Labor, or even overt skeptics, these individuals and this organization adopted in words and, more importantly, in deeds, the view that research is essential for national welfare. Such a view was common in the victorious nations, from Italy to the US, through France and Britain, and also in defeated Germany. It was de facto the policy in neutral countries, and if you look on Soviet science policy in the 20s, especially in the 20s, then it's a little different. It seems that it followed the same kind of idea. So, according to this view, original research, rather than merely the employment of extant scientific knowledge, so original research is needed for technological breakthroughs. Science is important not only as a reservoir for knowledge, but also as a method for studying the artificial as well as the natural for the practical ends. Of course, science as a reservoir of knowledge was also important, and they continue thinking about that. And that is very important, for example, for education, but it's important that what is the new ingredient that is very central here is the research. The societal economical expectations from science entailed not only a change in the society around science, but in science itself, and it also in the view of science by scientists. As a group, scientists became, and so as a group is of course a generalization, scientists became more willing to tune and even direct their research towards areas that are of interest to society through technological uses. So I will go now to more details of what I say in this general way. The enhanced expectation that science and scientific research would allow technological improvement originate in in the unprecedented role that science had played during the war. And it's the role that science and scientists, I will show the difference in a few minutes. And these are affected through two main ways. First is through the impressive success of scientists and scientific research during the war. So we have a few examples. I already mentioned them, so I will just do it fast again. One of them is the very strong example with the chemical research, where we have many uses of substitutes for many materials which were scarce by different reasons, either overuse or by blockade. There is, of course, the use of poison gas, which was very important, although not as it was a good, a strong promise, if we want, not from science, from technology, that was not fulfilled in the sense that it did not change the war totally, but it was very important. And what we have, another thing which is very important, is the nitrogen fixation, which is important both as a fertilizer and this was done already before the war, and also for productions of explosives, and that was in all countries. Now, while the technological value of chemistry had been well known before, physics also proved to be an additional powerful resources for technological development. That was a more new phenomena if we compare it to chemistry, which had a long tradition of being very close by to applications. And so this goes with submarine detection efforts, with sound ranging of artillery, both things of detection, but different things that we detect, and with wireless or the radio. The radio was developed during the late 19th century and the early 20th century, mostly by electrical engineers and inventors, but during the 1910s, it was much more dependent on the new vacuum tube or triode, which was, for understanding its properties, one needed a lot of physics research, and we see in the war immediately, especially with the French, which were the best in that, but also some of the Germans, the mobilization of physicists to work on wireless. In developing these devices and methods, both physicists and chemists carry out original research. By original research, I mean that they carried research into properties and questions which they did not know the answer for. So they looked at the interactions and of the phenomena related to what they are to the technological systems they are studying. So I'll give one example on from submarine detection. I'll give here the example that was successful during the war, and less important one, which is the passive submarine detectors, which is kind of microphones put in underwater and then called hydrophone, because they are underwater. It's not a sonar. Like sonar becomes important much later, or very much important a little later. And so what they had there, they had to detect, to understand how it works, they had to know how waves of our sound waves are propagated in water. This was something that was not studied before, and what salinity and temperature, how they and current, how they changed what you get. And they had to do also how the diaphragms are behaved underwater. What is the sensitivity of diaphragm? Which kind of changes you can measure. So there is a lot of research, scientific kind of research, which is of course very much into the application, because the goal is clearly improving ways of detecting submarines, because this was the strategic problem of the British and the Americans in the beginning of the war, until 1917, 18. So this is the kind of research. Now, of course, I don't say that all research that scientists made was of this kind. So notwithstanding this reliance on research in some fields, in other fields what scientists did is more the things that engineers do usually, or at least do in the modern world, and this is based on knowledge that is already there. So they not explore new things, but using the knowledge that they have. And this one point here, which is a good example, would be sound ranging for locating enemies' batteries, gun batteries. And then we have the story starts with the French astronomer Charles Nordman. He had suggested the idea. He was in the field actually, and he invented a system with sensors and microphones to locate through a few sensors where the guns was shot for. His system was brought to the British, and they improved it. The one who improved it was Lawrence Bragg, who just won at the same month is the Nobel Prize. But what Bragg and his other physicists did is they used knowledge that they had before. They also used and employed not only knowledge, they employed also some of their experience in the laboratory. So actually their sensor is based on Watson bridge, which is something very useful in the physical laboratory, and they just took it, made the right modification, and put it in the field. So to sum up, what is important, of course, is that whether their scientists succeeded as engineers more or as scientific research, the credit was often given to science. So to sum up this part, the success of scientists both in carrying scientific research and in applying scientific knowledge and expertise and in design of new technologies contributed to the view that science would be essential for material welfare and material advance. Another source for this expectation from science was that the fact that the perception of science by governmental officials, military men, and industrial elite was very much affected from the fact that they knew now these scientists from first encounter. So they knew them, they worked with them for a few years, and of course, often this was clashed, but it's also often the fact that they worked well together, so there was a trust between the two sides. So there were developments in technology and science, especially on chemistry and physics in the 19th century already led to some expectations, or even high expectations in the late 19th century from scientific research. We can think of the chemical and electrical industries, but as I said in the introduction, this was very much contested. So many people said, you need the science, but you don't need to do specific research for the technological aims. Scientists, in this reason that scientists and other supporters of investment in research saw the war as an occasion for demonstrating the potential benefit of research. So this is a time when we have to use the time, in a sense, for that. They expected that research supported by human and financial resources allowed by the war this kind of research with all the resources would realize the promises that they saw in the science. For example, the astronomer and scientific entrepreneur, I think this is the way to describe him, George Hale, believed that the expected American involvement in the war is the greatest chance we ever had to advance research in America. And of course, he and the other people planned their steps to advance research and to advance the belief in the fruitfulness of scientific research, fruitfulness for practical ends. Moreover, they advanced a particular view of research which is centrally organized, and it's centrally organized to address issues including some of them technological, but not only technological. Hale was an astronomer, so he thought that also a big organized research is also needed for astronomy, not only for very practical questions, or partly practical. The war had offered a great chance for these people also, since the emergency situation dismantled some of the opposition inside science, because some of the scientists were concerned about their autonomy in choosing research subjects under this kind of organized research. Now, under the war, they were willing to suspend the research for the war's effort. So this is, it's not only outside, it's also inside an opportunity. Despite earlier support, the idea that scientific knowledge and further research were needed for addressing the challenges of the war encouraged a strong opposition. And this was especially clear in the militaries and defense departments, but also from inventors and industry. And I think probably the best example for this need to convince in this practical value of science is the fact that at the early stage of the war, scientists were recruited to be combatants in the field. The two most famous examples, I think, are Mosley and Schwarzschild. Both of them died. Schwarz is not really in the field, but near the field during the war. Both of them were Mosley was one of perhaps the most promising physicists in Britain at the time, and Schwarzschild was a very famous and successful astronomer in Germany. But also Nordman and Bragg, which I mentioned earlier, were first field officers in the field, and only later taken to do research. The change in the policy resulted from a few factors. There was a change in the policy, and the central among this factor was, first was the fact that the war was prolonged much longer than anyone expected before the war. No one went to a 4 years war. Everyone went to a few weeks. But of course, there is no much point in making research for the next 6 weeks. You need more time for that. But it was clear quite soon that it won't change so fast. The other thing is that there were new the second thing is there were new technological challenges that the war put. And these technological challenges posed by the war put a strong pressure on military and civil organizations, authorities. So these new challenges, I can divide them into two kinds, or three kinds. One is those that originated in science-based technologies. In science-based technologies, I mean things like wireless, which was based much on science. This is more, here the challenge is more a promise than a problem, because you want to use what you can. There is not a problem. Of course, gas warfare is a very strong challenge and a problem that you need, means against gas also, not. And the latter is seen, can also consider that how science and more so technology not only solve problems but also makes problems. And of course, when it produces problems, it also produces the need to continue using science, because the science is the answer to the problem is through scientific research. And the other kind, which were actually more important during the war, is that originate in what I call industrial technologies. The most important technologies in this are those that are connected to the trenches, the fact that there was a trenches war, and these are the machine gun. Not much science there, but this is the great hero of the First World War. Not so much, perhaps more infamous hero than a good one. And the machine gun worked with the barbed wire. It's very important to get of them together. Of course, again, not high science there, but a very big problem for many. And a second kind there is the submarines. And the third challenge was the challenge which I'm not so know how to put there in this category, is this fact that there was scarcity of raw materials, and then you needed to find ways to substitute them in different ways. So the responses to these challenges were very much different from one place to the other. The French were the first to implement scientific research. There is a long tradition for that, and political reason. The British were later. It's also different from one place, from one arm to the other. Yet all these places established organizations that connected between research and military governmental needs. So these organizations coordinated between the researchers from the one side and their users, if we want, from the other. And this revealed a clear change in the attitude, especially of in the Anglo-Saxon world, where it was clear now that science is needed for technological development, something which was not so common in the views of especially British and American officials before. The US provide also the paradigmatic example of how institutional recognition became of the practical value of scientific research. Of course, it will be one example, and it's quite famous. I did not invent it. I did not find it in the archive. It's put in Kevel's books. So in spring 1916, Thomas Edison promoted the establishment and the funding of what they called the Naval Consulting Board. The idea was to direct the development of means to detect and locating submarines. What Edison had in mind, he suggested pursuing the traditional methods of the inventors, assembling the knowledge that you have, trying the methods, and see how you can get at the end the results, like he did himself so successfully 30 years earlier. So he dismissed the need to carry out further research on any related phenomena, and he said it would be useless to go on piling up more data at great expense and delay while we are free to use this ocean of facts. That's the Edison's idea. As Hale's quotation that I gave before suggested, scientists have had different ideas of how to advance, and they establish the National Research Council, the NRC, which is still operating today, and its focus, the most important problem that it tackles was the same problem of locating submarines. And it yielded much more promising, and after a few months, even much more practical results than Edison boards. And even before the war ended, the laboratories of the NRC, in practice, absorbed the facilities of Edison's board. And this success of the scientists versus the great inventor was quite understandable to military men and governmental officials. And I'll give one example for that. Admiral Griffin concluded that the military technologies, the first steps sometimes needed to be, in a sense, backwards into the unexplored regions where fundamental physical truth, I think that fundamental physical truth is a very important phrase here, and engineering data were concealed. So in order to advance in technology, we need to go in a little bit far away into the basic knowledge of the area, into the fundamental physical truths. And this, of course, this is not a scientist's view, it's the view from the officials. Such views about the power of science to lead to the desired and otherwise unattainable results had clear manifestation in the war's aftermath. I will start with the important practical dimension, which I think is important to remember that we're talking about promises, that it's very important that promises are not only rhetoric, but they have a very clear, or often they have, and what is more interesting, when they have a clear practical side for them. So what we can see is the connection with wartime organizations. I already mentioned the American National Research Council that started during the war. In the similar way, the British Department for Science and Industrial Research, DSIR, is also, I think, still working, and it's, or is it changing? It's changed its name, but it has a continuation of organization. It worked between the wars, which was established during the war with the war, with the emergency of the war, but with the thinking of we'll continue with that after the war. And the French had somewhat different idea of the direction of invention, which started after a little bit after the war, but continues with another organization, Office National de Recherche, which was little less successful than the others. We can see even this kind of continuation in Germany, although there, for political reason, it could not be institutionally the same way, but the German Notgemeinschaft der Deutschen Wissenschaften, in Wissenschaft, sorry, it's not in plural, was established, has its roots in the practice of the First World War. We can see also other research organizations that were established by or in close connection to different, not to the state as such, but to the military arms. And this is the British Admiralty Laboratory was founded during the war. The American Naval Research Laboratory was established in 1923, so it's very close by after the war. The Italian Naval Radio Laboratory, also, if I'm not mistaken, is during the war. The German were not allowed to invest money in research related to the military, but they still did it, not only secretly. That's an important difference. The number of research laboratories of commercial companies also increased dramatically. And I think what is more important even is that there was expansion and extension of the laboratories that were extant. They expand in size and in the research areas. So they made more what people would say scientific study. You can see it by the places where they published, for example, and in many more fields. I give two examples of new laboratories, new big laboratories. One is for the American chemical company DuPont, and we go also to the neutral, so the Dutch Philips also established its big laboratories just after the enough of the war. So it's really their part of the idea. And we have the fourth, perhaps less important, but still a new kind of support comes from philanthropic foundations, which started only there. And these were especially those related to the Rockefeller and the Carnegie in the US, but they help also science in Europe. But also you have also such in other countries like Rothschild in France help French science. The fact that all these people, especially the philanthropic foundation, went into promoting research also connected to the way that scientists changed their own view about what science do. So their willingness to do research in connection to practical uses. And apocryphal story told by Edward Andrade can illustrate this change in the view of scientists. According to Andrade, a toast at the annual Cavendish Laboratory dinner was, "The electron may never be of use to anybody." So the story seems totally fictitious. We heard yesterday Jaume put us the J.J. Thomson, what he said about it, so it does not seem that at any point J.J. Thomson wanted to say such things. But what this story, I think, does say, it testifies to the view of physicists of Andrade's generation. Andrade was trained during or around the First World War. And their portrayal of the older generation, as they portrayed it as hostile to technological use, and this showed that Andrade's generation viewed themselves as more open to research directed towards applications, or what they would prefer to say. So they gave higher value to this kind of research, to practical use of the research. And this illustrates the gradual shift in the value of physicists, who probably now saw research as applied research, or what they would like to call basic research with practical applications, as higher than their precedents, they had it higher value than their precedents did. The term basic or fundamental research is very important because it became current, at least in the Anglo-Saxon world, and it helped the collaboration between the scientists from the one side and the industrialists from the other, because unlike the pure science, industrialists can understand that it can go from these basic facts of physics, as Griffin said, to solving a practical problem. And for the physicists, this is not something very superficial for the application, for only knowing how to do one thing, but this is something very basic, so it could be used for many things. And this also, so they mediated between the pure and the specific applied research. It also captured the promise as seen in science, because science now is a basis for, so it's a basis for technology, is a basis for economic and societal advance. So science is a basic for further elaboration and uses. And of course, we can see also this kind of promise embedded in what is called the linear model of technological change. It's a very rough model. It's not, it's not a very strong one, but at least the idea that you go from basic research and you get at the end technological results. It does not say that this does not say that it's unidirectional. It's unimportant. The promise ascribed to science was manifested naturally also in post-war rhetoric. Rhetoric which has also other practical dimensions. So I give a few examples. In 1920, the French Minister of Commerce, Etienne Clemental, stated that the science can be said to play in the economical struggles of peacetime the same leading role that it played during the war. The former American Secretary of War said something very similar. Eliot Root predicted that the prizes of industrial and commercial leadership will fall to the nation which organizes its scientific forces most effectively. On this issue, the victorious and the defeated agreed. In 1925, the head of the German Notgemeinschaft, the lawyer Friedrich Schmidt-Ott, declared that Germany should advance in science to reoccupy its place in the competition for the world market. It's interesting one of the things that we can in the quote I chose is that we have a recurrent role ascribed to science in the competition between, or even struggle between the nations. The projection of the future competition reveals a view of international relationship as a kind of a struggle, and if one wants, it's even almost like economy as the continuation of war by different means. I'll complete this short survey with a similar statement from Italy. I found only one from the time of the war by the industrial Ernesto Brade, who emphasizes the close connection between national prosperity and the application of the principles of science to industry, and claimed that, and I quote, all industries, in order to succeed at home and to beat the competition on the international level, need a constant contribution of scientists. And all the quotations I gave are not of scientists, are all from around them. The view that science would be essential for national welfare due to the competition among the industrial nations suggests not only a promise of science for a better future, but also its threat as used by others. Its threat, like its promise, provided reason to cultivate science, because we need to go against the threats of that other nations will do it better than us. This promise and threat of science are similar or even the same as those of technology. So there's a very close relationship between the two here. The First World War suggests not only economic promise, but also moral disappointment. With the, and this, I mean, of course, there is the poison gas, but what I want to point here now is the international, what was assumed to be international character of science seemed to be disappointing, because the expectation that science would help reaching international cooperation did not materialize. And not before, not during the war, and even after the war, it ran into difficulties where the cooperation was replaced by war, economic rivalry, and boycott. Of course, it was not full, and the scientists did try in the 20s. There are scientists that did try to help for international cooperation, but as an institute, it did not give any some kind of international cooperation. Perhaps these contradictory aspects of the promise and threat originate in inherent tension between science as human universal quest for knowledge, where we have international quest, on the one side, and technology as means for fulfilling wishes. And the meaning of fulfilling wishes are always of specific groups, individuals which have their own interests. And as we know, different individuals do not have the same interests. To sum up, due to the experience of the First World War, society at large had higher material expectations from science. In particular, scientists and advocates overcame opposition to invest considerable resources in carrying out original research. Yet, at the same time, the view of science has been changed to a more collective endeavor directed towards societal needs. Consequently, scientific research received more resources and scientists more prestige, at least in some countries. There is a question about Germany here, but they lost some of their autonomy from societal needs and wishes. Thank you very much for your attention.
All right, we have time, 10 minutes or less for discussion.
I have two questions. One is, I got the impression by hearing you talk that that behind that is a story of winners and losers, because there are some sciences that got enhanced and are able to collaborate and are within these interests to compete in the world of market, to connect their science to these technology challenges. But there are also sciences that lose completely because the resources, economic resources, and go towards these other sciences. I'm thinking about the humanities and all these sciences. So I think there's also this part. And on the other hand, my second question would be about these collaborations. John Carson's book on the measurement of merit studied very in detail how the psychologists in France tried to collaborate with the military in France, and they were not successful. And he showed the strategies the North American psychologists used, and which were successful to collaborate with the militaries. So I suppose that there's much more on this to see how these scientists were able and adapted to this new environment dominated by the military and their ways of interacting and doing. So these would be my two questions.
Okay, so I'll start with the first one. First, when I mean here science, I speak English science, not Wissenschaft. So it's only natural science. I even said, I think, natural sciences. I tried, if I remember correctly. So I mean only natural sciences. Now, in the natural sciences, I don't think there are many people who lost in the sense of financially. What they lost is perhaps their idea of how science should be and how science should behave. So the fact that they thought that science should not examine questions only because they have someone in societal reasons to examine them, but to do them pure and not to think about applications. You find these voices in the 20s, that people are against that. But because what happened is that science as a whole got much more money. So it's not the fact that what you had before the war is usually the fact that the scientist got the budget of its department. So there was no much money outside that. After the war, so some scientists continue, some physicists continue doing that, others got more money. So of course, once the other gets more and you get less, the difference becomes bigger, and then you feel it. But it's so this kind of changes. So I think the question is, within the community, is more question of what is the aim of science and how do we think about it, So this is the one, and I think for the collaboration, of course, the simple answer is, of course, it is very complicated and changed from one point to the other. In some cases, scientists worked in their totally isolated, or not totally, but with a buffer from them to the army. So the army, they got a very clear tasks. So if your task is to locate artillery guns, you can have, but then of course it was so it's important who was the officer connected to that, but I don't go into all of this because of time.
So, thanks, Shel. I mean, I recognise and accept the story, the account you've given. What I'd like to hear a little bit more of, because I think it's very relevant to the theme of the conference of promises of science. You mentioned in passing that in the late 19th century, the value of original research was contested. So there were people who saw there was not promise in original research. Now, apart from Edison, whose sort of views I think are well known, I was wondering whether you could tell us more about perhaps where that contestation was coming from and what kinds of arguments were being given against the sort of promise of original research in the late 19th century, of which we see attitudes do change in the First World War.
So I know little about the arguments, but if you look on the actual practice, you see that there was very few, for example, commercial companies were willing to invest in research, not in chemistry, in physics. So it starts around 1910 with the very particular reasons that AT&T and General Electric had. So it's not with that AT&T needed to have cost-to-cost. They decided that they want cost-to-cost communication, and for that they could not do it without new research. Or at least that was their view. So if you look how the armies and the defense and the ministries, the different Ministry of the Defense reacted to the scientist idea that they need them for the research at the beginning of the war, it's very clear that for them, we don't need the original research. At the best, we need some engineers.
Okay. I mean, these are sort of evidence of absences, really.
Yeah.
Absence of private research, of course, particularly physics, and initial opposition maybe to more organised research in the military during the First World But there might be other reasons for that. So there might be other reasons for why it would not make sense for private companies to be investing in and building physics-based laboratories. There may be other reasons why the military were looking for other ways or didn't see the need for research. As you said, we weren't expecting a long, drawn-out industrial war. It was going to be a very short conflict, and that was the war plan of most countries before the First World War. So there would not be any expectation we'd want to start employing physicists for on long-term contracts and building laboratories.
But it took them more than that.
Okay.
Because by November it was clear that that there is a deadlock, and then so how long it will, no one knew, of course, how long it would take, and there are also, but I need to recall them that there were discussion, part of the discussion, especially in the US, for the importance of the pure science and all this idea was, of course, if you read this is much earlier, so I think 1870s, if you read science at that time, so for their idea of science is very much like engineering. And that's the way that you have the pure science against it. So it's all the talks about the pure science they have advertised. So.
Okay. Yes. Thanks, Joel. I have a question about the various ways in which science appears as a promise. So. In your story, it seems to be much more instrumental. So we have some goals as a society, national ambitions, and science could be instrumental. So it is the same struggles with other means. Whereas we also, and you alluded and sometimes a bit to that, but it was stronger in other papers now, there's also a moral or ethical appeal. So it promises a better society with better thinking. We have clearer method, so more detached, more rational, so better society. How is that played out? Because that, with your stress on machine guns and so, it doesn't really come into it. But is it part of the debate, or is that really a separate debate?
So, as much as I see it, is that there is a separation, or in less, the First World War encouraged very much the instrumental promise of science, and at the same time discourage the moral value, because in the sense also there is the discussion, as I mentioned, inside the scientific community is somewhat connected. So if science is a quest for knowledge, then it has some kind of a moral value, like connected to the idea of education in general, or German view of Bildung and so on. And this now it's much lower, and what you have is the more instrumental promise of science. Of course, this is different from why scientists carry the research. This is another story, but that's what I would see here. A tension, and as I mentioned, I think this tension is connection. There is a connection between the tension between science between technology and knowledge. So technology, of course, is based on knowledge, but there is a tension between the two.
Okay. I maybe have 2 points which are slightly different. First of all, to respond to ask you to follow up on what you've just said, I was thinking about Paul Foreman and Heisenberg. That Foreman argues that in the wake of World War I, there's actually a much more greater interest in a German culture. And indeed, you could argue that a lot of the eugenics of the 1920s is actually nothing to do with technology, but actually to do with what we would call a perverted, but nonetheless a moral approach to science. But actually my first point was something slightly different, which is that we take World War I as the crucial turning point, and we're focused on it. But surely we should also look at the fundamental economic changes that are happening then. In the British case, the coal industry, the international market for coal collapses after World War I. And that changes the whole basis of the country's economy. No longer could you rely on exporting coal to Italy, which was a major issue, because the Italians are now almost coincidentally, using electricity, getting their energy from hydroelectricity. The oil industry becomes much more important by contrast, and that requires industrial research, cracking technology. The automobile industry grows enormously. So my question here is, how much are we conflating two issues? One is the war, and the other is the fundamental changes which are happening in technology and the economy at the same time, but are not the same as the war. So these two.
Okay, so I'll start with the second. I think that what you have is, in a sense, the war, much of what the war did is accelerating things which were on the way or did later. So if I mentioned the wireless, for example, so wireless was very important. It was very important, had a very important economic part. So if you look what happens after the war, so we see after the war that AT&T invest their huge amount of money and people. Also the British, Marconi does it and others. But during the war, people did it much more, faster, more people were inside, so there is an acceleration. And also, perhaps, this is also the question, I think that it led, and this is more than acceleration, it led more physicists into that research. Because someone like Henri Abram, who was very important in what he did for the French valves during the war, and he had a few ideas. He was a professor at the Sorbonne. I don't see him going into this technological research, even if he gets a nice salary for that. Okay, but during the war, of course, he does it. So there is much acceleration, but more than that, I think in the view of in the view of the collaboration between scientists and the state. But of course, once I talk about the war, it seems as though it's a sole cause, and of course I don't want to claim that. So there are many factors there, and the reason why the war is why it's one of the reasons that why is the first war in which science is so important, of course, depends on the development of technologies before the war. So this, of course, is connected. Now, for Forman and Heisenberg, I made a small claim, or I mentioned that I'm not so sure about the German case for the outcome of the war on science. I think there are in Germany it is more contested. So there are, in general, in Germany, there are two very clear and strong trends. So you have these trends that you can see from Helmholtz and the other people in around him with Electrotechnology Association from the 1880s, 1879, and these people are very clear, and the PTR, these people are very clear for the idea of using science for advancement of technology. It is also very much connected to rational thinking and liberal ideas. And you have the more, let's say, right-wing, traditional ideas. So you have these two. And when I take from Schmidt, Otto, Haber, they are, of course, going to continue with Helmholtz. But there is a very strong anti-rationalist mysticism ideas in Germany, and the war, of course, gives it a boost because they are in the losing side, and in the sense not of science, but in the sense of the war. So I'm not sure how I put Germany here.